Guten Tag, meine Damen und Herren. Ich nehme Sie heute mit.
Good afternoon, ladies and gentlemen. Let me take you on a journey through my everyday life at CODESYS. There are many interesting positions to fill in the CODESYS group. For me, the nicest one is my place in the application technology team here in Kempten. We have both feet on the ground of CODESYS reality, and we hold our heads up in this CODESYS skies of 1,000 possibilities. With one leg, we stand in the very interesting field of developing user-oriented products. We develop libraries and often distribute them via the CODESYS store. We take care of the maintenance and further development of the application composer and create extension packages to adapt CODESYS to your requirements. The second pillar, the second foot, is in the broad field of consulting our customers. There, we help you to do your daily work with CODESYS as good as possible. We listen carefully when it comes to identifying concrete specific requirements. We stay in the conversation to constantly shed light on new aspects and discuss alternatives. We make suggestions and develop prototypes to illustrate the solutions we have found. And I would like to invite you to look over my shoulder when I have my first conversation with Mr. Sproll.
Mein Name ist Dietmar Sproll. Ich bin Softwareentwickler.
My name is Sproll. I'm a software developer with Liebherr Mischtechnik. The Mischtechnik, Mischtechnik is in Bad Schussenried and part of the Liebherr group. I myself work in the machinery industry, so that means I'm a software engineer for the concrete mixing machines. Every year we produce in Germany, in Bad Schussenried, between 50 and 80 concrete mixers. Well, we have 4 product rows and series. As you can see, we have the Better Mix. The Better Mix is a compact mixer for transport concrete. So I have here the specific components of a mixer. So we have a mixer. Here the components are mixed. Then we have a dosage system where all the individual components are dosed. We have different silos. So a concrete silo or surcharge silo. Then we have also the loading, which is basically specific to the stone, how the stone is transported into the mixer. And then at the end, of course, we have the concrete delivery, which is then basically delivered through a specific lane. Well, I got told that on a basis project, another project is there. So missing blocks are developed. So for the operation, basically, this system project is adjusted on site. I/O connections are changed, probably misunderstood requirements are corrected, and then on the premises of the customer, everything is commissioned. Then, of course, it could be the case that customer-specific adaptations need to be taking place, and then we have version 3 of the system project. And with every adjustment of requirements, there are program copies in order to adjust, of course, everything to the customer's needs. Thank you very much for the multiple information I tried to get out of the distilled information that I will let you know in the next days. Is that okay? Yes, thank you very much for the time, and I look forward to your feedback. Well, thank you very much. Thank you. During the transition from CODESYS 2.3 to CODESYS 3X, the shifting of code from the application into libraries is important and plays quite strongly. Of course, the result is reusable function blocks, which are stored in versioned libraries under source code control and are thematically grouped together. by structuring of code in functional modules, we can ensure that developers only need to understand the module to be changed in detail. Only superficial knowledge of other modules is necessary, for example, knowledge about the interface. Modules delimit a small, natural part of the content in the entire system, and this makes them relatively easy to understand, to implement, test, and document. These modules have a uniform interface and therefore can be generally commanded and called. Modules can be integrated into a hierarchy as subordinate or superimposed parts of the whole. So, what else do I suggest to Mr. Sproll? Well, come with me.
Hallo, Herr Sproll.
Mr. Sproll.
Hallo, Herr Doll.
Oh, hello, Mr. Doll.
Seit dem letzten Mal.
Well, since our last call, I've put some thoughts into your requirements that you've had and on how I can fulfill them. So I noted some things down, so I would like to introduce that to you and show you. And if you have any questions, if anything is unclear, just shoot and let me know, and then we talk about it. Oh, I'm looking forward to it. So we talked about modularization. Now it's about the question, how can we make a very quick modularization and split up into modules? I suggest having a module hierarchy and split up our system in order to get a hierarchy in 3 areas, and also in order to find a rule where we can say which hierarchy level, which module and which functionality shall be implemented. So that means there is a basic distribution between process and equipment. So that means the processes are separated just clearly from the program of the setup, basically, of the equipment. Processes determine which quantities of which raw material are mixed with which RPM in which time. The raw material containers, the mixture component, etc., they are part of the equipment then. So therefore, in the context of the standard, there are 2 different models that should be implemented separately. So the process model and the plant model. So in the standard, there is a hierarchy, or 2 hierarchy levels, one for the process model and one for the plant model, whereas they are assigned to each other. So there's a plant, a partial plant, a plant part, and below that we see different devices, field devices. And a field device is implemented because of its individual function. And plant part provides basic functions, and the plant part are the functions. So the plant is controlled by a recipe or a specific process. Let's ask the question whether the term of field device is okay. Every field device has a direct connection to the process. Typical field devices have the following characteristics. They get just simple instructions: open, close, start, stop. They control equipment parts into a specific state, so open, closed, active, or stopped. So information according to the current operational state or error states can be notified as well. So a field device can be as simple but also as complex as possible. And in the following you see some different examples. So valve, a group of valves in a valve aisle, a pump with variable speed that is together with a flow meter ensuring a specific flow speed and flow volume. Let's assume we want to control the flow volume. So we use a pump, which has specific RPM, and also a flow meter. A PED regulator measures the volume and sets the RPM of the pump. The process parts. So the logic of the plant only wants to control the flow rate and then looks at different things as one field device. Although this field device exists in the plant, not all parts need to exist physically. In our example, the PED regulator can also be just a library block and doesn't have to be a real device that physically connects the pump with the flow meter. So what we could do is basically we could develop into this direction, and probably the next time we exchange which control modules exist and how can they be combined, collected. So my homework for you would be just to go through whatever you have, what specific examples can be used, and how can we exercise it using a specific example. Is that a good suggestion for the next meeting? Yes, definitely. I think we have still a lot to do. Great, so let's leave it like this. Have a nice afternoon, and then see you soon. Thank you very much. Bye-bye. So after the first attempts to create a modular application manual, after some time, the CODESYS application composer was introduced. With that composer, modules can be assembled into hierarchies in a very elegant and time-saving way. The interactive connections of the modules to the appropriate inputs and outputs is very well supported. Parameters can be defined for the modules, which are then taken into account when building the application. The most important states of modules can be managed with the persistence manager. Let Mr. Sproll tell us how the project has developed in the last 2 years.
Wir haben unsere Mischanlage nun versucht zu
Well, we tried to modularize our mixer, our concrete mixer, just as we talked about in the last meetings and as we defined it. And our system, our plant, was separated into material sources. Here we see the concrete silos. Then we also have the surcharge silos. And in addition, we have the additional material containers, which are defined and were combined as one system. Then we have a dosing element. Here we have the concrete volumes, just also like water and additives. Then we have another separate dosage unit, which is responsible for the dosing of the surcharge silo. And you can see here, everything is separated, but the function is the same. Then we have an additional module, which is the transport lift, the feeder that feeds the material into the mixer. Then the next part is the mixer that actually just mixes the material that came from the source or the silo. And then we have the concrete output, where the material is delivered into different containers. So let's talk about the hierarchic software concept. So we have a plant compound from different production sites. So below that we see different plants or production sites that can work off tasks individuals. So just like the concrete mix. So we have units. They are basically working off partial tasks. For example, in our case, feeder, dosing, and so on and so forth. And then we have the parts of equipment that control autonomous processes. So, for example, the mixer or the delivery belt. Then on the lowest level of the hierarchy, we have the field devices that have a direct connection to the hardware. So they just have simple processes, and they can depict engines, motors, or valves. Just very briefly with regards to the application process, what it looks like now. So we use the application composer. I have a concrete mixer here where you can see all the modules in place. We created template projects that we can load and open here, for example, for a better mix system that consists of the different modules. The application process now, compared to the previous application process, is that we open a template project. Then the template project is edited, meaning we add the modules just as they are specified. And here in this example, you can see that the Wiegeband engine or motor is a simulation motor, and I can select from a library what type of motor it is. So we have this ABB drive or a manual drive. So we can just pick and select from a different variety of motors. And what we can also do is we can adjust the parameters of the different modules. So that means the application is only an application on module level. So I don't have to write any codes. I just change parameters and configurations. Exactly. The next point is the hardware connection. It's quite a nice tool that comes with the composer. So the hardware can be connected via drag and drop. So I have the hardware tree in the development environment. I have my module tree, and the hardware can be, as I said, connected via drag and drop, and I can attach it to the respective hardware. And then at the end, the composer automatically generates the SPS code, or the application is loaded to the PLC, and the application process is finalized. So the new application process is described as the following. So we have the framework, the application framework, which is provided in the form of a library. The development department develops the components in there, writes functions and tests the modules. The application department can use the specification from the configurator and can generate the application, can connect it to iOS, parameterize and configure it, and then also commission it and also be ready for the service and support. So that means with quite a few development colleagues, a lot of quality can get into the application department. Is that right? Yes, that's right. And the majority or the vast variety of functions has lost its fearing or the fear-creating bit. So I just have here, when it comes to the reusing of components, we have the same modules in different projects. For example, I have a module tree of a Betomix, and I also have an HPC high-pressure cleaning project that's supposed to become part of the project. So you see it's a specific control. So you see the tree, how it is basically set up itself, and here we can see the same modules. Here we see, for example, digital inputs. We have pump engine, as we saw it before, that can be replaced by other motors or engines. So the components, the field devices, I didn't have to create them new. I could actually reuse existing modules. Yeah, congratulations. So we really like that as well. It took us a lot of sweat, blood, sweat, and tears basically, and helps us in the future. We accompany our customers quite a lot, and we have different tools at our disposal when it comes to consultation. The exchange of questions and answers, the creation of examples or prototypes, short-term meetings according to your needs, regular meetings, for example, with the exchange of to-dos, workshops for the joint development of solutions, service according to your specification. Successful consulting makes itself dispensable from time to time. We accompany, we consult our customers for a longer period of time. Ideas and tasks need to be developed by the customer themselves from time to time. Of course, there can be times where different meetings are set up. So I would like to invite you to talk to us about new tasks at the info stand. Thank you so much to the company Liebherr, to Mr. Sproll. Thank you, ladies and gentlemen, for your interest, and have a nice afternoon and interesting presentations. Thank you very much.